Hi, I'm Kristin Tolle from Microsoft Research. I'm in the Microsoft Research Connections team. And the core tenet that I like to live my life by is to be a force for good in the world. So this quote by Mahatma Gandhi is very important to me. It's one I like to apply to my own research, to the research of my collaborators, and also to the students that I work with as well. I also work to create collaborations between the external researchers and folks that are inside of Microsoft Research to then do tech transfers and publications, advancing the science much more quickly. So the goal really is to be able to facilitate time to discovery in all the different areas that we work on. I'm in our Microsoft Research Connections team, and there's 5 themes that we actually do research in. Everything from core computer science to education and scholarly communications. There's Earth, Energy, Environment, Natural User Interface, and Health and Well-Being. In fact, I've been in all of these themes except for core computer science. But they all really kind of work together in ways that create exceptionally interesting projects that I've had some hand in as I've worked inside of Microsoft Research. So I'd like to show those to you. But before I do that, I know one of the questions that people wonder, here we are, we're talking about this core computer science lab and, computer science researchers, what does this matter to me? How is this going to affect my life? But it's really going to impact everything that we do. It's going to affect our lives in many different ways, resulting in a safer, healthier, and a better future for all of us. I'd like to show you how that's going to work. Here's a project that I was working on, and it brings in NUI, it brings in health and well-being together. If you look at these images, they look a little bit distorted. But what you're seeing, that E that's on the screen there, that's actually written on a contact lens. So imagine having a heads-up display that would come up on top of your eye. This is something that's not too far away. We've got a project that we're working on with some researchers at the University of Washington where they're developing a contact lens to create such a system. Right now it's actually being used though for diabetes, since we aren't able to get a whole sentence on there, as you can see from the letter E. That's kind of difficult to get a whole sentence if the letters are that large, but we can actually put LEDs on there, like for instance red, amber, and green, to let somebody know where their diabetes is. So if you think about that, the functional contact lens really would change the lives of people with diabetes by being able to put it in their eye. It checks the blood level of sugar level, glucose, right directly from the eye, because essentially anything in your eye is almost similar to the same things that are flowing through your blood. So it would really change the life of people who have diabetes, particularly those that have to go through the process of taking their blood every time they eat, or even in between meals, punching their finger many times a day. Now for adults, that's something we can probably tolerate, but think of the children that are actually born with this particular disorder. It's painful and it's difficult for them. So if you look at this picture, my husband's a doctor, and I asked him, I said, what do you think is the dirtiest thing in this particular image? And I can't actually repeat what he said, but what I want you to take away from that is actually that the keyboard is actually the dirtiest thing, because a lot of different hands touch the keyboard, and so it could never remain sterile. So imagine this being inside of a surgical room where a doctor wants to be able to pull up your MRIs, your CAT scans, your x-rays, and has to walk over to a keyboard. That's not very sterile if he touches this particular keyboard, even if they sterilize it. So in some cases, they were even pulling the cuffs of their robes down and knuckling it. So one of the things we're going to do is monitor staph infections inside of a surgical theater by employing a new technology, which is using the Kinect to be able for them to gesture in the air to bring up different types of visualizations of the body of the patient while they're in the surgical unit. The next project I want to talk about is one with David Heckerman. That's a health and well-being combined with a machine learning or some of the computer science aspects. And what they're trying to do is actually understand ways in which we can help mitigate the AIDS epidemic. So if you don't know it already, and I'd be surprised if you didn't, 1.8 million people die every single year of HIV, and 5,000 of them die every day. So that just kind of gives you a sense of really how horrible this particular epidemic is. But what we've discovered, or I should say David has discovered, is that you could take something as simple as a spam filter to understand how AIDS mutates in the human body. So just like think about the way in which junk mail spam gets into your system. Well, he actually created a technique that would allow you to see how that spam morphologes inside of different spamming activities to catch it and be able to put it in your junk folder. Spam filters are just learned from representation. As you click that junk button, it goes off. Well, the same thing happens inside of the human body. And because we're all human and we all have our own DNA, HIV actually also changes within our body in a very unique way. So the thing to do with that is to be able to understand how it changes within my body, but also look for the weak points. So if you look at this image, actually what we're doing is we're seeing the different epitopes where there are weak points, places that are common across people where we could target a virus that would actually prevent people from contracting AIDS if they had a vaccine. Another one that's in the area of NUI is in the area of cultural preservation, and this is very near and dear to my heart. It's the Microsoft Translator Hub. So we work directly with communities who are trying to preserve their languages for future generations. And in particular, one I like to mention is the Hmong Da. Hmong is a culture that's actually displaced. They have large groups of them that are in Australia, in France, and in the United States. But just like you would think about it, these folks want to integrate into the culture where they are living right now. So it's very important for them to, adopt their home country's language and traditions. But they also don't want to lose who they are. And so by creating a translation system between Hmong and English, we enable them to actually be able to educate even their children. They can go back and they can look at some of the old songs and some of the old chants and things and be able to understand their history a lot better as well. It also gives us a window into their world so we can go back and look at this language and understand what their belief systems were. It sort of makes the world a little bit smaller. At least I like to think that it does. So one of the more recent projects that we did is we went down to the Yucatan and we met with the Mayans, and we worked with them to develop a Mayan to Spanish translation system so that they could do the same thing. And we were able to launch that on the day that the world was supposed to end, the end of the Baktun in the Mayan calendar. So that was a lot of fun as well. But this is a tool that's open to anybody. You can go out and you can create your own custom system, either in a language that you want to preserve or even to create a particular translation system that would be very customized to your needs. So for instance, if you're in industry and you want to be able to have one that's tuned to, say, trucking or automotive or to education, if you're an educator, maybe you want to map it to that, or a particular level of science, you can create a custom system that will be highly precise between two languages. One of the things I've been working in most recently now is actually global climate change and global health and how it impacts global health. And one of the things that we know is that climate change is happening. And we want to make sure that we enable scientists to do their best work in trying to help us understand that and be able to understand how it is that we can live better, fuller lives, whether that's with being able to understand when to plant our crops, or it might be just ways in which we can find out where the big problem spots are so that we can help keep our planet clean and protect it for future generations. The problem is that scientists today face a big dilemma, right? They're dealing with lots and lots of data of heterogeneous type and trying to bring that all together into the different tools that are out there, which are also very disparate, is a problem for them. So it can be a big challenge. So what we're trying to do is help facilitate that. But what we found is even within our own organization, our researchers were building individual tools to solve problems for themselves. And so we're using almost them as a model for how we're going to be interacting with the public. So they'll build a tool that does one thing, and then they'll build another tool that does a different thing, and then they'll build a third tool, but none of these tools actually talk to one another or share data amongst them, and so that's a problem. And this is happening inside of Microsoft Research. So what we want to do is facilitate that with our local researchers, but then also help people who are out in the scientific community, because invariably what happens is these tools don't work together and you have to rework them. Our goal is really to be able to make all of the tools work very well together, that we can integrate tools even from the outside that other researchers are building or other companies are building, be able to bring that into a common interface where people can actually exchange data, collaborate well, and be able to solve some really tough global challenging problems. We want to help the field scientists that are out there collecting the data. We want to be able to help the computational scientists who are writing scripts in order to be able to further their own research, and we also want to help policymakers make very good decisions based on very good data. And bringing that data together, being able to model that in such a way that we can actually make excellent predictions is one way that we can help policymakers know what changes need to take place in order for us to secure our future on this planet. It's a small world, and there's a lot of big decisions that we need to make to live healthier, happier, safer lives. And I'm very, very pleased to be a part of working on this particular research area. Thank you very much for watching. I'm Kristin Tolle, and I'm with Microsoft Research.